Educational GMAT. Your partner in your GMAT journey.
All right. Passenger cars sold in nation X from 1965 to 2010. This is not at all difficult, actually. So this is year, and these are the cars sold. And notice the trend line has already been drawn for you, so you don't have to visualize what the trend line would look like. For the year in which greatest number of passenger cars was sold, that number was approximately dash, and these are the options, greater than that indicated by the trend line. Okay, all right. Now, first of all, we obviously have to figure out for which year the greatest number of passenger cars was sold and which is that year.
1985.
Notice greatest number of passenger cars is this, and this corresponds to the year 1885. So for this year, right, basically that number means this number was approximately how much greater than the number indicated by the trend line, right? So in 1985, the trend line indicates how many cars? $200, right? 200, correct? Am I correct? No, no. Okay, this one. Yeah, yeah. 2,300,000, by the way, right? So the trend line indicates in 1985, the trend line indicates 2300000, right? Because this is in thousands, correct? So essentially 2.3 million, while the actual number of cars sold was how much? How much is this? 2,900, right? This one, 000, correct? So clearly this is 600,000. This is 600,000 more than this. Okay. So 600,000. Okay. All right. The number of passenger cars sold follows the pattern. Okay. By the way, there's an if, I think, here. If the number of passenger cars follows the pattern of the trend line, approximately how many passenger cars will be sold in 2055? Did you get the question? If the number of passenger cars sold follows the trend line, so basically if it continues in a straight line, then how many passenger cars would be sold in 2055? So as Rohil is rightly pointing out, this is clearly related to the finding out the slope. And how do we find out the slope? dy by dx, right? Slope is always dy by dx. So essentially, given the data that we have, right, between these 2 years, so how many years have passed? From this is 1965, right? And this is 2010. So how many years? 45 years, right? And the change in the number of cars would be how much? The change in the number of cars. So this value, okay, I'm getting all confused here. How much will this value be? 19, right? 1900, correct? So this is basically, actually, let's be very clear. Slope is equal to dy by dx. So dx is 45 years, and this is 1900,000 minus how many cars were sold in 1965? 2600, correct? Uh, this is 2600. So 2600,000. So that would be how much? Minus 700,000 upon 45. So now minus means what? There is a decrease in the number of cars sold. And what is the decrease? This is the decrease in the number of cars sold per year. So that's the slope, right? We have to find out how many cars would be sold in 2055, wherever 2055 is, right? So 2055 would be somewhere here. Can someone tell me how do we find out? How do we find this out? So in 2010, how many cars were sold? Nine, correct? So in 2010, 1900,000 cars were sold. And from this point onwards, for the next 45 years, why 45 years? Because from 2010 to 2055, that's 45 years. For the next 45 years, the number of cars sold would continue to reduce by these many cars per year. So total reduction would be how much? Minus 1000 upon 45, right? That's the rate of reduction per year. And this rate of reduction will continue for 45 years from 2010 to 2055. That's 45 years. So obviously this gets cancelled. So then we are left with 1200, right? Basically 1900,000 minus 700,000. So that's 1200,000. Yes, 1200,000. So straight application of slope. Any doubt, guys?